Hello, this is the last video about metals in this topic, and it's on extracting metals. In the first two videos, we've talked about the reactions that metals do and how to use our observations from those reactions to figure out which metals are more reactive than others. In the end, we were able to put the metals into a list called a reactivity series. The method that we use to extract metals from the ground all depends on their reactivity. You may remember that before we categorized metals into three groups: high reactivity, mainly groups 1, 2 and 3 metals, medium reactivity, mostly transition metals, and low reactivity, those metals that don't react with water or acids and very rarely react with oxygen. The low reactivity metals can be found naturally in the ground. We say that they are found pure or in their native form, because we can just simply dig them out of the ground, just like they did in the gold rush so many years ago. The only reason we can find them as pure metals in the ground is because they are so unreactive that they don't react with water or air very easily. These will be the metals that we use for jewellery, such as gold and platinum. All the other metals are so reactive that they're normally found in the ground as compounds that we call ores, which are metal compounds found in rock. So that means if we don't find them pure and they've already reacted to form a compound, we need to do some chemical reactions in order to obtain the pure metal. For the rest of the metals, there will be two main ways of extracting them. If a metal is less reactive than carbon, then we can carry out a reaction called reduction with carbon, and that will remove the compound from the metal, leaving the pure metal behind and giving us carbon dioxide. If the metal is more reactive than carbon, then we can't use this method, because carbon is not reactive enough to remove the compound from the reactive metal. So we need to use a different method, and it's normally electrolysis. You haven't learned about electrolysis yet, so we'll talk about this method of extraction later on when we're talking about electrolysis. So for now, let's look at the reaction which involves reduction with carbon. Let's take copper oxide for example. Copper is a metal that's reactive enough to be found in the ground as an ore, and the ore is normally made up of copper oxide or copper carbonate. If you react copper oxide with carbon, the carbon is more reactive and so will take the oxide away from the copper, leaving copper behind and creating carbon dioxide. This is the equation for the reaction, and we would balance it like this. And it's a reduction reaction because the copper is losing its oxygen. The carbon in the meantime gains oxygen, so while the copper is reduced, the carbon is oxidized. Unless you're doing higher tier, you only need to be able to explain reduction in terms of the loss of oxygen. So, carbon can be used to extract metals from their ores by reducing them from their metal compounds into the pure metal. If you are doing higher tier, then you need to be able to explain it in terms of electrons. So we said on the last slide that the copper is reduced because it lost its oxygen. In terms of electrons, in this compound the copper is a 2+ ion. Once the reaction is finished, the copper is an element, and that means it has no charge at all. To go from a 2+ charge to no charge, that means we must gain electrons. Because you'll remember that electrons have a negative charge, so we need to add 2 negative charges to 2+ to make it into 0. If you remember oil rig, oxidation is loss of electrons, reduction is gain of electrons. So that means that the copper is reduced. Carbon changes from an element into a compound, and although it doesn't change into an ion here, it is losing electrons, and so we can say it is oxidized. So in a situation like this, when oxygen is directly involved, we can explain redox in terms of the gain or loss of oxygen, or in terms of the gain or loss of electrons. But be careful to get them the right way round. Remember, if you're not doing higher tier, you're not expected to know about redox in terms of electrons. You're only expected to be able to explain it in terms of oxygen being gained or lost. So that's all for this section about reactions of metals. Here are the useful keywords from this video, and I'll catch you on the next topic.